And I'll start with the demo of the faults and fractures plugin. So what I have here is a dataset with a number of pre-cooked elements, and the faults and fractures plugin is started from this icon over here, and it has many different attributes that can be computed. It has different filters to pre-process the data or to enhance the data by skeletonization, so thinning the output. You can extract fault planes, and there are tools, utilities like calculating rows diagrams. Now, let's first have a look at a few filters. And I've already got a few filters displayed over here, so we can just compare that. I'll switch off the horizon so that it's not in front of us. And I first go and look at this seismic line. That is my input seismic line. This is how the seismic is what I got. This is after dipstick median filtering, so that is just removing the random noise. And this is the edge preserved smoothing filter, so that is much sharper, the edges. It has also really averaged out everything, so this is not really to be used for quantitative interpretation anymore, but it can be really useful for input for structural analysis and for computing the fault likelihood, for instance. Now, what does the fault likelihood look like? That looks like this. This is based on a semblance calculation, and the semblance is calculated in different directions. That is different dip directions and also different azimuth directions. So you're really specifying, if we look here on how that is done, the fault likelihood is this attribute. Just press go. I specify my input, and this could then either be the dipstick median filter or the edge preserved smoothing seismic. And then in the advanced settings you can see that we are computing these semblances in 25 different directions, and also in the dip between 25 and 65 degrees in 6 different steps. And the result of that looks like this. Now, this in itself is not very useful. It becomes useful if I either thin it or I use it as input for automatic fault plane extraction. So if I thin it, then it looks like this. That is the thinned fault likelihood, and you can see, because it was used from the EPS, it really follows the faults here very nicely. Okay, that is just a few inputs that you can directly do from the faults and fractures plugin. I also have a few predictions from machine learning, and I just want to show these as well. So this again is my original seismic. This is the EPS smooth seismic. This is the TFL from the smooth seismic, and this is a UNet that is applied and predicted on this line, the fault likelihood. So it's a three-dimensional application, so I have this everywhere in the 3D seismic. So this is before thinning. I can then skeletonize it and get a response which is more like the TFL. I also have a fault net, but only in this small portion over here. And if we look at that, you can see this is really a much better predictor than the previous UNet. This is very sharp, and this is even before thinning, compared to this one, which is the three-dimensional UNet, and this is the fault net. The fault net is giving me a better predictor. Okay, back to faults and fractures. I would like to demo now the automatic fault plane extraction, and for that I switch on my horizon again. I switch off this line. Let's move it over here. I'm going to compute this only in a small area around this horizon where we do have these nice faults. Extract planes is the tool. I'm doing that from the fault likelihood, and I'm doing it only in a subvolume. Run it. So from the fault likelihood we are now looking for which faults belong together, which outputs belong together and can be combined into a fault plane, but this is not really a fault plane yet. Let me switch off this one. These are, if I zoom in, you can see these are individual points, and these points have been collected to become what is called a fault skin, and that is kind of grid which from which I can create fault planes. In seismic interpretation software, a fault plane is basically a collection of fault sticks which are then interpolated to create a fault plane. So if I want to convert this into a fault plane that I can also use in other softwares, I have to extract these and sample them with fault sticks so that they can then become fault planes and be used in other softwares. Now what we see here is a rows diagram where each of these fault planes falls. We see these sliders, and I can use these sliders to remove some of the smaller elements. Yeah, can also remove faults running in a certain direction or faults running dipping in a certain range. If I want to extract a fault plane, then I can select a fault plane, and I can also say, okay, this looks like one fault plane, so I can select more of these. These three, they should be merged and become one fault plane. Then I can say, okay, merge the selected ones and extract these, and I will call this TMP merge 3. Okay, now what has happened is that I have created a new fault plane, and this is a real fault plane, and I've removed all the skins from my set of skins so that I can individually select all the ones that I want to have. So if I do not show the skins, then you can see here this is the one fault plane that I've now extracted from the entire set. And the smoothness of this fault plane is something I can control by how many fault sticks I want to save this particular skin in, and how much in which direction the fault sticks should be oriented, either horizontally or vertically. Now if I then think I've selected all the ones, then I can say, okay, let's select all fault skins and convert all these in one go. Don't merge them, extract them, and I would have a complete set of fault planes. That is the idea.